Tina, I'm sorry, but I just can't get on board with your global warming theories today. Look at this. I'm wearing a heavy wool coat in the middle of May. If the planet were actually heating up, I should be in a t-shirt by now. This feels like global cooling to me.
I hear you, Leo. It is freezing today. But you're making the classic mistake of looking at the weather and calling it climate. They are related, but they operate on completely different timescales.
I've heard people say that before, but it sounds like a convenient excuse. If it's cold here, it's cold. Why is that not a sign that the Earth isn't warming?
Think about it like this. Weather is your mood, but climate is your personality. You might be a generally happy, positive person. That's your climate. But if you have one bad day where you're grumpy or sad because you lost your keys, that's your weather. One bad day doesn't change who you are at your core, right?
That's a fair analogy, I suppose. But how do scientists actually track this personality of the Earth?
They look at long-term patterns. When we talk about weather, we are talking about what happens on a day-to-day basis. Will it rain at 2 p.m.? Will it be 5 degrees or 15 degrees tomorrow? That's weather. But climate is the statistical average of that weather over a very long time, usually 30 years or more.
30 years? That's a long time to wait for a weather report.
It has to be, because the Earth's systems are huge. To understand the climate, scientists calculate average temperatures from thousands of locations all over the world. The oceans, the tops of mountains, the deserts, and the icy poles. When they add all those numbers together, the trend is clear. The line on the graph is going up.
But if the average temperatures are going up, why are we sitting here shivering?
Because the Earth isn't a microwave that heats everything evenly. It's a complex system. When you add energy to the atmosphere, which is what global warming does, you make the system more chaotic. Think of a pot of water on a stove. As it gets hotter, the water starts to bubble and move around violently.
So you're saying the heat is actually causing this cold snap?
Indirectly, yes. For example, there's something called the jet stream, a circle of wind that keeps cold air trapped at the North Pole. As the Arctic warms up faster than the rest of the world, that wind circle becomes wobbly. It starts to leak cold Arctic air down into places like where we live. So even though the entire planet is warmer on average, we get these strange, intense bursts of cold weather.
So, while I'm complaining about my frozen nose, somewhere else might be having a record-breaking heat wave at the exact same time?
Exactly. Last year, while parts of Europe had a very cold spring, parts of Australia and the Arctic were experiencing temperatures 10 to 20 degrees above normal. If you only look at your own backyard on a day-to-day basis, you miss the fact that the rest of the house is on fire.
Okay, so if I understand you, the long-term patterns are the real truth, and the weather is just the noise or the fluctuations around that truth?
You nailed it. Think of a person walking up a hill while playing with a yo-yo. The yo-yo goes up and down, up and down. That's the weather. But the person is still walking upward. That's the climate. Even when the yo-yo is at its lowest point in the air, the person is still higher up the hill than they were 10 minutes ago.
That makes a lot of sense. I guess I was just looking at the yo-yo and ignoring the hill. But doesn't the climate change naturally anyway, like the ice ages?
It does. But those natural changes happen over thousands or millions of years. What's happening now is that the average temperatures are rising in just decades. It's the speed that is the problem. We are changing the atmosphere's personality so fast that plants, animals, and even humans are struggling to keep up with the new moods of the weather.
So, more heat in the system means more energy, which leads to more extreme stuff? Not just heat, but also bigger storms or weirder winters?
Precisely. Warmer air holds more water vapor. That means when it rains, it pours harder, leading to floods. But in dry areas, the heat sucks the moisture out of the ground faster, leading to worse droughts. It's all connected to those long-term patterns.
I feel a bit silly now for complaining that global warming was a lie just because I needed a scarf today.
Don't feel silly. It's a really hard concept to grasp because we experience life in the now. It's hard to imagine the global average when you're personally feeling cold. The important thing is to look at the data provided by experts who are measuring the whole world, not just our local part.
Well, the weather is telling me it's time to go inside and get a hot coffee. But my understanding of the climate is definitely a lot clearer now.
I'm glad to hear it. Just remember, one cold day is a data point, but 30 years of rising heat is a crisis.
I'll remember the yo-yo and the hill next time I see snow in April. Ready to head in?
Lead the way.
You know, Tina, I've always loved this botanical garden. Even though it's freezing outside, it's so warm and tropical in here. How do they keep it so warm without a giant heater?
It's actually the design of the building itself, Leo. This is a greenhouse. The glass walls let the sunlight in, but they don't let the heat escape. It's the perfect place to talk about what's happening to our planet.
Wait, are you going to tell me the Earth is inside a giant glass box?
Not exactly. But the Earth has something called the atmosphere. It's a layer of gases that surrounds our planet. Think of it as a giant, invisible greenhouse for all of us.
I've heard that word before, the greenhouse effect. But it usually sounds like a bad thing in the news. Is it?
That's a common misconception. The greenhouse effect is actually a natural process, and it's a good thing, mostly. Without it, the Earth would be a frozen rock with an average temperature of about minus 18 degrees Celsius. We wouldn't be able to survive.
So the atmosphere is like a heater?
Not a heater, more like a blanket. Imagine you are sleeping in a cold room. Your body produces heat, but if you don't have a blanket, that heat just floats away into the air. When you put a blanket over yourself, it traps heat next to your skin. The blanket doesn't create the heat, it just keeps it from escaping.
Okay, I like that image. So the Earth is the body, and the atmosphere is the blanket. But what is the blanket actually made of? It's just air, right?
Well, the air is mostly nitrogen and oxygen, but there are special gases called greenhouse gases. These include carbon dioxide, CO2, methane, and even water vapor. Even though they make up a tiny part of the atmosphere, they are the ones that do the heavy lifting to keep us warm.
How do they do that? Do they reflect the sunlight?
Actually, it's a bit more scientific than that. The sun sends energy to Earth in the form of light. This light passes right through the atmosphere and hits the ground. The Earth absorbs that light and turns it into heat. Then, the Earth tries to send that heat back out into space.
And that's where the blanket comes in?
Exactly! The greenhouse gases act like the fibers of the blanket. They let the sunlight pass through, but they catch the heat trying to leave. They trap heat and send some of it back down to the surface. This is what keeps our oceans from freezing and our plants growing.
So if the greenhouse effect is natural and keeps us alive, why is everyone so worried about climate change?
Because, Leo, we are making the blanket too thick.
Too thick? Like adding a second blanket in the middle of summer?
Spot on. For the last 150 years, humans have been burning coal, oil, and gas to power our cars and factories. When we burn these things, we release huge amounts of extra carbon dioxide. We are basically adding more and more fleece to the Earth's blanket.
I see. And if the blanket gets too thick, it traps too much heat.
Precisely. The planet's average temperature starts to rise because the heat that should be escaping into space is getting stuck. That's what leads to melting ice caps and rising sea levels.
It's a bit scary when you put it that way. It's not that the sun is getting hotter, it's that we are losing our ability to cool down.
You've got it. And remember, it's not just CO2. Things like industrial farming and landfills release methane, which is an even stronger greenhouse gas. It's like adding a layer of plastic wrap to the blanket. It traps heat even more effectively than carbon dioxide does.
So, if the atmosphere is full of these gases, can we just thin out the blanket?
That's the goal. That's why scientists and leaders talk about reducing emissions. If we stop adding extra greenhouse gases, the atmosphere can eventually find a balance again. Nature has its own ways of removing CO2, like trees and the ocean. But we are currently adding it much faster than nature can take it away.
I used to think the atmosphere was just empty space. I didn't realize it was such a hard-working system.
It's a very delicate balance. Just a small change in the concentration of these gases can change the temperature of the entire world. Think about when you have a fever. Your body temperature only goes up by 1 or 2 degrees, but you feel terrible, right?
Yeah, I'm exhausted, and my whole body aches.
The Earth is the same. A global warming of just 1.5 or 2 degrees Celsius sounds small, but for a whole planet, that's a fever. It changes weather patterns, kills coral reefs, and makes storms much stronger.
So, the greenhouse effect is our best friend because it keeps us warm. But we've turned it into a problem by making it too strong.
That is the best summary I've ever heard. We need the blanket. We just don't need 5 of them.
I think I'll look at this greenhouse differently now. It's a great way to remember how lucky we are to have an atmosphere and why we need to protect it.
I'm glad. It's a big topic, but when you think of it as a cozy blanket, it's much easier to understand why we need to keep it just right.
Definitely. Now, let's go find some of those CO2 absorbing trees you mentioned. I think there's a forest section in the back. You know, Tina, I was reading an article last night about the Arctic. It said the ice is melting much faster than scientists predicted 10 years ago. It feels like the world is on fast forward. If the climate has always changed naturally, why is it happening so quickly now?
That is the million-dollar question, Leo. You're right. The Earth has gone through warm and cold periods before. But those changes usually took thousands or even millions of years. What we are seeing now is happening in just decades. The main reason for this speed is human activities.
Human activities? I mean, I know there are a lot of us, but are we really that powerful? We're just tiny people on a huge planet.
We are tiny, but there are 8 billion of us, and our lifestyle requires a massive amount of energy. Think about your day so far. How did you get here?
I drove my car. It was only a 10-minute drive, but it was too hot to walk.
Right, and that car runs on gasoline, which is a type of fossil fuel. When we burn fossil fuels like coal, oil, and gas to power our cars, heat our homes, and run our factories, we release billions of tons of carbon dioxide, CO2, into the atmosphere.
So it's like we are pumping extra blanket material into the sky every single day?
Exactly. Before the Industrial Revolution, the level of CO2 in the air was quite stable. But since we started burning fossil fuels on a massive scale, those levels have skyrocketed. We are changing the chemistry of the air much faster than nature can adjust to it.
Okay, so burning stuff for energy is the first big reason. What's the second? I see those workers over there clearing that small forest for the new shopping mall. Does that affect the speed too?
Sadly, yes. When we cut down forests, we lose our best natural defense against climate change. You remember from biology class that trees are like carbon sponges, right?
Yeah, they breathe in CO2 and breathe out oxygen.
Exactly. Trees inhale carbon dioxide and store it in their trunks, roots, and leaves. When we cut down forests, a process called deforestation, 2 bad things happen. First, the sponge is gone, so it can't soak up CO2 anymore. Second, when those trees are burned or rot, all the carbon they were storing for years is released back into the air at once.
So it's a double hit to the planet. We add CO2 by burning oil, and we remove the things that clean it up by cutting down trees.
You hit the nail on the head. Agriculture is another big part of human activities. To produce enough meat for 8 billion people, we clear massive amounts of land for cattle. Those cows also produce methane, which is another very strong greenhouse gas.
It's starting to feel like everything I do, driving, eating, buying stuff, is making the problem worse. It's a bit depressing, Tina.
It can be overwhelming, but that's where the concept of a carbon footprint comes in. Have you heard that term?
I've seen it on social media. It's like a measure of my impact, right?
Yes. Your carbon footprint is the total amount of greenhouse gases produced by your personal choices. It includes how you travel, what you eat, and even how much trash you throw away. By understanding our carbon footprint, we can see where we can make changes to slow things down.
But if I stop driving my car, does it really matter if big factories keep burning fossil fuels?
It's a mix of both. Individual actions help, especially if millions of people do them. It sends a message to companies. But you're right, we also need big changes in how we get our energy. We need to move away from fossil fuels and toward things like wind and solar power. These clean energies don't pump CO2 into the sky.
I guess that's why people are talking about electric cars and solar panels so much lately. They are trying to shrink the carbon footprint of the whole city.
Precisely. The goal is to reach net zero. That means we don't add any more CO2 than the Earth can naturally remove. If we can reach that balance, the rapid warming will eventually slow down and stabilize.
It's amazing to think that in just 150 years, human activities have changed a system that was stable for thousands of years. We really have a lot of power over the Earth's future.
We do. And because we are the cause of the fast change, we also have the power to be the solution. It's about changing our habits and demanding better choices from our leaders.
Well, for a start, I'm going to walk home today instead of calling a taxi. It's a small step, but I guess it's one less bit of fossil fuel burned.
That's a great start, Leo. Every mile walked is a win for the atmosphere. Plus, the exercise is good for you too.
True! Although, if I walk, my human engine will need more food. I'll just make sure it's a salad instead of a big burger so I don't increase my methane impact.
Now you're thinking like a climatologist.